Welcome to the Retro Junction.
Oh my god. Oh my god, I've done it. Oh my god.
What?
I did it.
What'd you do?
I've done it. I did it.
Hey guys, welcome back. I have something to show you today that I'm pretty excited about. So, as you guys know, most of the retro computers use the 2364, 2332, 2316 family of ROM chips. C64, VIC-20, PET, Ataris. The list goes on. The TRS-80 has some. I honestly don't know what all computers use this chip, but several of them do. And there are options out there to replace these chips with, 2764s or 2864s, any number of chips like that. But, usually when you see them, the standard one you see a lot of would be something like this, where you have a board that adapts the pinout of the 2364 to work with a 2764 or 128, 256, what have you. So the main problem with that is a lot of them, not all of them, there are some out there that can work with, that can work with the character ROM and the kernel ROM and basic ROM in a C64, but most of them have limits as far as that stuff goes. So I decided to try my hand at making one that did not have those limits, and it's finally done. I am going to make, I'll show you the schematic here in a few minutes. I'm going to make a couple of physical changes, but this is electrically how it's going to turn out. And one of the main things I was trying to achieve was cramming everything on the bottom, so from the top it looks like a chip. And hopefully you can see that with the glare. But here's the top side of the board. The only thing up there besides, the traces and vias and stuff. I also made the vias small enough to where the solder mask would cover over the vias, so it would be black. There wouldn't be any, silver vias on here. But the only thing that's up there is the orientation marker. And then here's the bottom for you. So this chip is using a SST39SF010A. It's a flash ROM, so it's flash programmable, and I wanted to be able, I made a couple versions before this when I first started getting into this, where it was you programmed it once, soldered it on the board, and then that was it. That's what you had. Well, this one I wanted to be able to make it reprogrammable, so I put, if you can see on there, I'll try to get closer, hopefully it focuses. You have the extra address pins, as well as write enable and output enable. Those are there, and then here's the programming adapter I made. And this one's actually, the final version doesn't normally look like this. You see there's two sockets there. That's only because I wanted to use these smaller pins. With this particular set of pins, I found these on DigiKey, but they came from Germany. But with this particular set of pins, it sits at the exact same height as a regular chip. So if you put this in a socket on the C64, for example, it will be the same height as the chips next to it. The regular one, and what the normal layout would be using these SIL turn pin headers, and with that you can use a regular socket like this, a blade socket, dual blade socket or dual wipe socket, and just one of them, and then your pogo pins stick up through the middle. And to program it, well, first of all, here's the way that it's configured to allow you to change, to allow it to work with all these different configurations, is by these jumpers. And the main thing here that makes it a little bit different than all the other stuff is that the 2364 and the 2332 and the 2316, they were made by Commodore, and they were factory programmable. They were mass programmed ROMs, and they could be factory programmed to have their chip select pins be either active high or active low. Now when you get a new ROM, like a modern ROM, 27, 32, 64, 256, whatever, or in this case the 39SF010, the chip select, first of all, is going to be one chip select and usually one output enable, but they can kind of be used in the same way. But the main thing with them is they're always active low. That's basically the standard, and has been for a couple of decades now. So the main reason that you can't use some of these other boards, in place of, or for both the kernel and the character ROM, say in a VIC-20 or a C64, is because one of the chip select pins is active low or active high, one or both of them. So what I've done here is this little tiny chip here. This is a dual inverter. So with these jumpers down here, if you put the jumper in the top spot, the one on the right here, if you put it in the top spot, that routes the chip select pin directly from the board to the chip, to the 39SF010. If you put it in the bottom position, like it is here, you can see this one is actually down. This will run the signal through the inverter and give you the inverted output, so it'll make an active high input to the board. It will invert it to active low, so it will function with this chip. And because of that, it allows it to be used in basically every situation that uses a 2364, 2332, or a 2316. And then also I pulled up, there's supposed to be a resistor pack here. They didn't come in when I built this one, so I just put 4 resistors, and then there's another 2 resistors here. What I did was I routed all of the address pins are pulled low through this resistor pack, and then not write enable and not output enable are pulled high to deactivate them. And then when you plug them into the programming adapter or the computer, it can pull them whatever direction it needs to, which in the case of programming obviously would be low. So beyond showing you this guy, I wanted to show you the schematic here for it. And then also I'm going to show you, we're going to do one, I'm going to show you programming it, and then I'll show you, I'm just going to show you the programming once just to save on time, but I'll show you when I set the jumpers in order to change which device I'm going to connect it to. So today I'm going to show you the C64's kernel ROM, the C64's character ROM, which is normally one that people have trouble with because one of the, on the character ROM on a C64, it's chip select 2, I believe, is active high, so that is where you would run into a problem with a lot of these replacement boards. But on here we'll just invert it and it won't be a problem. And then I'm going to show you an Atari cartridge as well. These use a 23, most of them use a 2316 or an equivalent to that, and it can also replace these. Now in the Atari cartridge specifically, they just pull the 2 chip selects, chip select 1 and chip select 2 are just held high, and the chip that's originally in here has an active high chip select. So again, this would be a problem for these other boards. They wouldn't be able to do this, but for the one that I made here, all we have to do is invert them and be good to go. And most of them will actually work. Most of the devices, it can actually configure this in a couple different ways that will work. For example, like with the Atari cartridges, you can use this jumper over here, the one that's actually that's soldered right now. You can use this jumper to connect not output enable and not chip select together. And then when you do that on, like, say the Atari cartridge, that's what this is set up for at the moment. But you invert the chip select 1, so run that through the inverter into the chip, so it's pulled high on the Atari, so that pulls it low to be compatible with this chip. And then you can jumper this pin to connect those two pins together. You could also just jumper this side to switch it, to invert the signal and not connect this one. It would work both ways. I'm sorry, not connect this one. So short these two, and then open this one, and it would invert both of those chip select signals, and it would work either way. And that's true for several of the devices I've tested it on. There's more than one way you could configure it. But all right, let me show you the schematic real quick. Here real fast. I mean, I think you already saw it some, but this is like the standard layout of the programming adapter. And then I made it so you can use the square pins for the bottom, so it's a little bit cheaper. The main reason that I wanted to use the SST39SF010 is that these chips cost like $1.45 or something like that from DigiKey or Newark, Mauser, whatever. Whereas, like, say the 28 C64, they cost like, I think it was like $6 or $7 for those. And I don't know that I would have had room. I actually made a version that used the 28 C64 that would only work in those certain situations, like, you know, when the chip selects were both low, etc. But it takes up the majority of the bottom of the chip, and I wanted to make sure that from the top it looked as much like a chip as possible. And I actually have future plans to change it a little bit more to make it look even more like an actual chip, but I have to wait to do that until the parts become available. But anyway, hopefully you can see this some. We're not going to go through this in great detail or anything, but here's the schematic. This is the 39 SF010, and then that just all goes up through data bus. It's pretty much tied one-to-one, except for the extra address lines that exist on the 010 that don't exist on the 2364 or 2332. And then one other thing I wanted to note real quick while we're talking about that is you could also use this to do ROM switching by soldering a wire to, once you programmed it, soldering a wire to any of the address pins there, and then the other side either to ground or to +5. Although they're tied high anyway, but so you'd basically be grounding them. And if you did that, you could use a switch or a rotary switch, whatever, you know, to do ROM switching if you wanted to do that. That wasn't the goal of what I did here, but it ends up working out that way. And on a future version, I might end up adding a VCC and a ground pad down here just to give you a convenient spot to hook up the power side if you do want to do switching. But yeah. So up here you have obviously the 2332 and the 2364, and then here, let me get my little pointer. Here you have 20 and 21 on the 2364. On the 2330, or on the 2332, excuse me, on the 2364, 21 is actually A12, and you see that noted here, but I set it up like a 2332 because it's the difference. So anyway, the jumpers, you can see you got a jumper here, 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 and here. So if you wanted to have it configured for a 2364, just straight through and through to a chip select pin that is active low, so one-to-one basically, all you have to do is you jumper 1 and 2 on JP1. That will route chip select 1 directly into chip enable on the 39010. And then for a 2364, you need to connect A12, which is also the chip select 2 pin. So you take 21, skip, you don't connect JP2, so you don't connect this at all, and you don't connect JP4, and then you connect JP3, which attaches this line to A12 and disconnects it from output enable. And then if you're going to do, say, a 2332 that had an active high chip select 1 and chip select 2, so you've got both of them in this case and no A12, so the signal that would be A12 is now chip select 2. Say they're both active low, so you would take CS1, bring it over here, jumper 1 and 2, connect it to chip enable, not chip enable, sorry. And then for CS2, you would come down here and then you would connect pins 1 and 2 on JP2. That would connect chip select 2 to not output enable, and you would disconnect JP3, which they're all disconnected by default. So if you don't want them connected, you just don't bridge them, and then you bridge the ones you do want to connect. But anyway, that will disconnect A12, which is pulled high, so it won't float. It'll just go high when you do that, and then you'll have output enable activated. And then the other way you could do it, if you only wanted to use one of the chip selects, like I said, you can, most of the devices you can actually configure it a couple of different ways. So if you had a 2332 that had 2 active low chip selects, right, you could say take chip select 1, route it through 1 and 2, and then connect JP4, which connects output enable and chip enable, not output enable and not chip enable, together. And then when you get your chip select for that pin, you'll get both of them. And then you would just leave the other 2 disconnected, so you wouldn't connect any of these. So you would connect 1 and 2, you would leave this jumper, or you would connect this jumper, sorry. And then since it's a 2332, you would leave this open because you don't need A12. And then you would leave this open because you're going to get that signal from the other chip selects. So that would tie the chip selects together so they operate at the same time. But that's the schematic. You can pause it and look at it if you want. Oh, and then I guess one of the important things to point out is I'm going to put this up for people to make their own. So I'm either and or going to put it on PCBWay through the shared projects thing, so you can just go on there and order them, or make a GitHub for it, so the schematic and the board files and all that will be available. I may sell some of them on like eBay or whatever for the people that don't want to take on soldering the 39SF010, because it's a TSOP 32. It's a small package, but if you can drag solder, you'll be able to solder this chip with no problem. Same with these things. And actually, on the newest version, which this is the new and final for now, I guess, version, I made the components, this resistor pack and the capacitors on there. There's a cap. I don't know if you can see it here and over here. I made them a little bit bigger just to make it easier. But all right, let me set the camera up so I can show you the programming, and then I'll show you it working on a few different devices. Okay, sorry for the amateur hour screen recording, but I do not have a capture device yet. Show you real quick this. Actually, hold on, I have my focus locked. Okay. That's your configuration for programming the chip. So when you put it in the adapter, you'll have JP1, which is on the right, in the 1-2 position, and then you'll have this one next to it in the closed position, and then the other 2 will be open. Alright, let me lock my focus again, and I've actually been programming these on my other programmer, but I figured I'd do it on here just so you guys could see, because this is what everybody's going to be using. But obviously let me unlock this thing again. To do the to put it in the adapter, it's as plain as it looks. You have the orientation marker here, and then the orientation marker on the board. You just put it, sorry, let me get that up so you can see it. Just set it in with the 2 on the same side, and then push it on. And then the pogo pins on the adapter will connect to the pogo pin targets on the adapter board, on the chip, so to say. All right, throw this in the programmer. On these, I'm using the this guy. You guys, this is the one most of you guys would be using. Obviously, this is the what do they call it? TL866, I think. Mine is the T48 version, I think. But it'll work on the regular one and the T56 one. So you're going to go to select IC, and then it's going to be SST39SF010A. If you don't pick the A one, it will work just fine. So select that, and then what I've done with the go up to load to get your file, and the way I've done this is first of all, you don't have to turn off the check ID or the pin detect or any of that. You'll just program it as a straight DIP32 SST39SF010A. You can leave all the other stuff alone because as far as the programmer knows, this is a DIP32 SST39SF010A. So I guess we'll go with the C64 first. That's what I've got up here. And I've got, so the way I've got these files set up right now is I took the files from Zimmer's in this case, and then I just programmed them. I just loaded that data into every block that it would fit to on the chip. So I just copied it over and over again as many times as I had to fill the entire chip. If you took the time and the effort, you could just program it into the exact sector of the chip that you needed to. For example, say you were going to go from like 0 to 7 FFF or 3 FFF, whatever it may be, 1 FFF. I don't know off the top of my head, but you could just do that, especially if you're going to do the switching, ROM switching. Just figure out what the addresses it needs to be are, and then program them only into that address. But what I've done for all the files I'm going to show you today is I've converted them to work just to fill the entire chip. So here you have C64 kernel 39SF010. Open that guy up, and then just open it up as normal. And then, like I was saying, if you go down through the buffer, this goes to 1 FFFFF, I think. No, 1 FFFF, sorry. But it's just repeated in here as many times as I had to repeat it. And then after that, just hit, well, in this case, this chip already has something on it. So I'm going to go ahead and erase it. If it was a new chip, obviously, you wouldn't have to do that. But, all right, so that's already done. Doesn't take long to erase. And then go ahead and program, and then program. And it will program the flash in the chip. And then go back, and if you wanted to, obviously you could do the verify. I mean, it already did this, but I'm gonna do it again. All right, so there's verify finished, back, and then you can pull this out of the programmer. And then for most of the devices, you'll have to switch the jumpers on the board on the chip replacement to after you program it, before you put it in your device. You'll have to configure them for that, for the chip that it's replacing, for the device you're putting it in, etc. But in this case, for the C64, for like the kernel, you can actually leave the jumpers in the same configuration that you have them for programming, and it will work in there. It'll work in the C64 in the same configuration it was programmed in. So let me hop over here. I'm gonna show you guys. I'm going to film, I guess, just the TV, but maybe I'll show you the chip in the board or something, just so I don't have to switch the camera back and forth over and over again. But let me get it set up. Alright, so here's the C64. This happens to be the 425, which is the super common version. This one has kernel 2 in it. I just programmed kernel 3, but either one would work, obviously. The jumpers are set. I didn't have to change them because, like I said, for the C64, for the kernel and the basic ROM, you can just leave them as they were. Alright, so I'm going to pop this in and then let you guys see what it looks like in the board. So if you have the pins that I have on this one, the normal one, which would be this configuration, it will stick up a little bit higher. It still looks good. But with these particular pins, and that's why I wanted to make this, is it will fit. It sits basically the same height as the other chips. I don't know if you guys can see that really, but there you go. Yeah, it sits like exactly the same height. And then I have a different set of pogo pins coming in that should make it to where I didn't have to do the whole double stacked socket thing to make it work. They should just go in place of these ones and work with these pins. But anyway, there's that. Okay, I'm gonna flip it up to the TV here and fire it up. So here we are. Got the C64 with my board in place of the kernel ROM, kernel version 3. And fire it up, see what it does. Alright, so there you go, it's working with my kernel replacement. Oh, I can't load anything, I don't have anything hooked up. Let's try, oh, hold on. Alright, so there you go, working as it should. I've messed around with it, you know, everything seems to work fine and reliably, etc. Okay, let me reprogram it for the character ROM, and then I'll show you the jumpers for that, and then we'll see what it does with the character ROM replaced. This is, remember on the C64, the character ROM is a 2332, and I actually brought, I actually printed out schematics to show you guys this. This is actually from a 25469, but for this part of the, oh here, let me switch you down, hold on. Okay, so for the character ROM on a C64, it's a 2332, as you see here, but most importantly for what I'm going to show you is chip select 1, you see here, active low, that's normal. But the reason that most of the other replacement boards wouldn't work for this is because of chip select 2 is active high. Now on my board, what we're going to do is it's just tied to 5 volts. So this line's held high all the time anyway, but we're going to run it through the inverter so it's held low and then run that into output enable. So I'll program it, I'll show you the jumper settings for it, and then we'll see it working. Okay, I've got the board reprogrammed and I've got the jumpers set. So here's how I'm going to do the jumpers for the C64's character ROM. JP1 is just going to route chip select 1 directly to chip select 1 on the C64, and then for chip select 2, since it's active high on the C64, I put this jumper in the downward position, so 2 and 3, in order to run it through the inverter, and it'll be held high on the C64 board, which will be inverted to hold it low, and that will go to output enable on this chip. And then you have the other two not connected. Now, like I said, you could do this multiple ways, or 2 different ways that I've noticed so far. You could also leave this one, what would it be? I think disconnected, and then jumper this one to connect chip select 1 and chip select 2 on this chip. That way it would be using the chip select 1 from the C64 to activate output enable and chip select on the 39010. It would work in both configurations, but I wanted to show you it this way because it shows the using the inverter. So we'll throw this in to the character ROM spot, and then I'll get you back up on the TV. Oh, and then same thing with the programming. I just loaded the character ROM information in every place on the chip. So I filled the chip up with copies of the character ROM's data, and that's how it's programmed. All right, I'm gonna switch back to the TV. Okay. Same C64 with the kernel 2 put back in it, and then my board in place of the character ROM. And fire it up here, and there you go. Same thing, working just as normal. Not going to type out this whole thing again, but obviously you can see the character set is loaded in and working correctly. Alright, next I guess we'll switch to the VIC-20 and we'll do the character ROM in the VIC. Let me get everything set up. I'll show you the jumpers and show you the chip and the board, and we'll go see what happens when we plug it in. Alright, so this is a original VIC-20, as in not the cost reduced version, but I have my board, and actually forgot to show you the jumpers. Let me pop this out. If I can find my little tool here, where to put it. There we go. The hardest board to get this chip out of that I've seen so far is the VIC, and it's not hard per se, it's just the angle's kind of weird. I don't want to use, normally I'd use a little, I'd use this thing to pop the chips out that are in sockets, but I don't want to use that on my board because I don't want to scratch it, and then also I don't want to hit the little inverter chip that's under there with the point of that. But I just get in both sides and pry upward until it pops out. But okay, so here's the, where'd I put it? Okay. Here's the schematic for the VIC-20, or at least part of it, and here's the character ROM, and you can see it's a 2332, but unlike in the and actually the schematic is wrong, I'll show you that, or at least it's got one detail that's actually pretty important wrong, but this is the 2332, and you can see CS1 and CS2, so we have both of them on this chip, as all the 2332s do, but it actually shows them active high here, and that's wrong. They're both actually active low, whereas on the C64, CS1 is active high, CS2 is, or CS1 is active low, CS2 is active high. On the VIC-20, even though the schematic doesn't show it, both of these are active low, just like they are on the 39010. So in that case, here's your jumper settings. It's just 1 and 2 on JP1, which is here. Sorry, I can't get it to focus. 1 and 2 on JP1, and then 1 and 2 on JP2, and all that does is just routes them directly from the C60 or from the VIC to the 39010. All right, so I'm put it back in here, and then we'll go up to the TV and I'll show you it working. Okay, we're hooked up to the TV. We have the VIC-20 with my board replacing the character ROM. Oh, and I wanted to point out too, I'm not showing you the reprogramming and changing the jumpers just to save a little bit of time, and mostly so I don't have to keep moving the camera back and forth from the computer to the TV and all that. But to change the jumpers and reprogram this chip takes like a minute, if that. I mean, for me, they're right next to each other. It's probably like literally 30 seconds. I can change the jumpers, reprogram it, change the jumpers to the device I'm putting it in, and be done with that in about 30 seconds to a minute. But here you go with the my character ROM replacement. And again, you can see it's working. If it wasn't, we would have no characters. Go ahead and do one of these, I guess. Same deal. I've messed around with it. It's perfectly stable and works exactly how it's supposed to. All right. Now the last one that we're going to look at is the Atari 2600, and the Atari 2600 doesn't have a ROM in it, but the cartridges use either a 2316 or a 2332, or I guess in some cases 2364s. But this board will work with 2316s. I've tried it in my TRS-80. ROM C, I think is what they call it, as a 2316. It worked fine in there. And as far as I've seen, all the schematics I've looked at with 2316s, it will work in place of that as well. Just setting the jumpers and programming it as such. But I'm going to, we're going to do Defender here. and I'll show you it once my chip is in there and everything, but we're going to change, we're actually going to keep it the same. I'm going to take the chip out of this and put my board in there, programmed as Defender. So just going to replace it one-to-one. But let me get it reprogrammed and set up, and then I'll show you everything. Alright, so here we are. I've already taken this cartridge apart, and I tested this previously a little while ago. Here's the board, and what I've done to make this easier for future changes in case I want to change the game in this cartridge at some point, I have actually put individual, I'll show you once the chip's out, but there's individual socket pins in there. So it's socketed, but it still sits all the way down. This allows me to pop it out easier. But this is the game Defender, and I'm going to pop it out and put my board in there, and then I'll get it up to the TV and show you. Again, this is a, in this case, this is 2316. There's no marker for the direction. I put this little black mark on mine to show the notch, but just line it up. Oh, and here's the little socket, individual socket pins I put in there. So same deal, just swap it out. I programmed this already with the with Defender, with the ROM for Defender. But here's your jumper settings. Oh, that's not your jumper settings. Let me change them real fast. Sorry, got ahead of myself. This one, they have the 2316, and both of them are active. Both of the chip selects are active high, so they'll need inverted. And they actually just tied both of them to 5 volts. So the chip select, so to say, on these Atari cartridges is done by the by address lines. The chip selects themselves are just held high, but because they're active high, we need to invert both of them. And actually, for this one, I did switch them, and you could do it like this, and it will work, where they're both just in their inverted position. But I'm going to show you another configuration because we haven't done it yet. Let me take that jumper off real fast. Okay, so the other way you can do this is just connecting chip select 1 to the inverted setting, and then put this, it's jumper JP4, but I'm going to rearrange their labeling to make them make a little more sense. So don't go off of that in the future. It will be just the labeling that's changed. But so what I've done here is connected JP4, shorted it. So that's just going to tie JP1, and it's going to tie chip select 1 to chip select 2. And more so, I guess, it's going to tie on the 39010, it's going to tie output enable and chip select together. Okay, so I'm going to throw this in and show you how that sits. Again, this is with the shorter pins, so if you make it the normal way, so to say, it'll sit higher than this, but I did it this way so it could fit, and that's why I did the little individual socket pins instead of a socket, so it could fit inside of its case. But there you go, that's the board in, and let me get it set up there, and I'll show you it working. I wanted to go ahead and show you the board in here. I didn't put it back in its case. It will fit like this. I'm not sure if it'll fit with the regular longer pins, the just the turn pin ones, but just for demonstration, I'm just going to put it in here like this. And the board, or the cartridge, the chip, sorry, faces the back, which is weird, but that's how they did it. Okay, now let me put you up to the TV. Okay, we're back on the TV, so I'm going to turn the Atari on. This is the Atari with Defender and my board, and my ROM replacement board. And what did I do wrong? Oh, wrong input, sorry. I'm going to switch to the input. As you know, or as most of you know, I'm sure, the Atari is RF out. Okay, so we're on channel 3. Now let's turn it on. Alright, and there's Defender. And I actually hooked up the joystick. So there you go. Working as designed. Looks like crap because it's RF, but yeah. That's going to be the last one I'm showing you on this video, but there you can see it working. So that's 3 different devices, 4 different configurations. I've tried it on my TRS-80 and a 21 or a 2316. That worked. I've tried it in several things that I have here, and every one of them has worked that I've tried. And as a little bonus to the people that have stuck around this long in the video, I ordered like 10 of these as prototypes, so to say, but they're in their final form basically. But I also ordered 10 of the programming adapters, and I really want to have this thing tested with more devices, just to, you know, ensure that it works. So what I want to do is, in editing, I'm going to put an email address up on the screen, and if you guys have any devices that have like a 2316 or a 2332, and especially those devices that have active high chip selects, if you want to send me an email and tell me what device you have so I can see if it's got what I want, I will send you one of these boards pre-assembled and one of the programming adapters pre-assembled for free. I'll pay for shipping and everything, but I have 5 of them that I want to send out. So if you have a device that that has the active high, especially the ones that have active high chip select inputs, so I can test. I'd like to test more of the inversion part of it. But if you have a device and you would want to test this and you would like to get one of these boards for free and the programming adapter that goes with it, just send me an email at whatever I put up on the screen there, and then let me know what you have. And as always, thank you guys for watching. I really appreciate anybody who's subscribed or liked the videos. It helps a lot. I haven't been on here that much, but I've also been busy making this board and then a couple of ones before this that did the same thing, but not as configurably, not as universally. And then also names for this board. I've just been calling it the 2332 or 2364 32 universal replacement. Obviously that doesn't quite roll off the tongues, or off the tongue. So if you guys want to leave any ideas for names in the comments, or if you want to leave a comment or just bits of knowledge, anything, I welcome it. And thanks. We'll see you in the next one. Bye.